Hey everyone, Mr. Voigan here. We're on Unit 10, Lesson 2, and we're going to be continuing on with systems of linear equations. And it looks like we've got an exploration here, and there are three burger restaurants, the Burger Shack, Big Burgers, and the Burger Haven. And there's going to be some people there purchasing burgers and salads and paying various amounts of money for various ratios of burgers and salads, and we just want to try and find out the price of burgers and salads at each one of these restaurants. So what we want to do is definitely make note of what's in the first line here in A, where we need to make our let statement. So we've got two unknowns, the cost of a burger and the cost of a salad. So we're just going to assign one of them to X and one of them to Y. So we said let X be the cost of a burger and Y be the cost of a salad. So when I go look at the Burger Shack, for example, on the first order, there's 4 burgers and 2 salads. So it's 4 times the cost of a burger plus 2 times the cost of a salad, and that was $28. And the second order had 6 burgers and 1 salad, and the total cost was $34. Okay, now I'm just going to move down to part B, and it says to write each equation in the slope y-intercept form and determine the cost of a burger. So if we take this first one, 4x plus 2y equals 28. I'm going to first move the 4x to the other side by subtracting 4x from both sides. Then I'm going to divide everything by 2 to isolate the y, so we get the, in the proper format, y equals negative 2x plus 14. And the second equation, which was 6x plus y equals 34, this one's a little bit easier. I just need to subtract 6x from both sides, and the coefficient in front of y is already 1, so we end up with y equals negative 6x plus 34. Now I've already input these into the calculator, so if I go right here and go to the y equals, you can see there are the two equations in the proper format, and then I set my window to negative 20 and 20, both for x and y, and I graphed it, and now we've got where the two lines cross, and that is the intersection, and you can see that it gives us the coordinates 5, 4, and those are the x and y coordinates. And if you go back to our let statement, x is the cost of a burger and y is the cost of a salad. So the answer in this would be a burger is $5 and a salad is $4. Okay, let's move on to the next restaurant, Big's Burger, and the first order came in with a burger, so X plus 3 salads, and the total cost for that was 18. And then we had 3 burgers plus 9 salads, and the cost was 54. So if we move down to part C, it says take a look at those two equations, and we're going to need to compare them. So to compare them, again, we will put them into the slope y-intercept form. Okay, so the first one, x plus 3y equals 18. I'm going to move the x over, so I end up with 3y equals negative x plus 18. Divide everything by 3, and I get y equals negative 1 over 3x plus 6. Okay, and the second equation is 3x plus 9y equals 54. So I'll move the 3x over to the other side. I'm left with 9y equals negative 3x plus 54. Then I divide everything by 9, and I end up with y equals, and not only are we going to divide by 9, but we need to reduce down to its lowest terms there, and we're going to end up with negative 1 over 3x plus 6. So what do we notice here? Well, both of these equations are identical. So it's crossing the y-intercept at 6, and it's a negative slope going down, 1 down, 3 over. So we basically have a line going like that, and the second one would essentially go right on top of that. They're the exact same lines. So in this case, there isn't just one intersection like the part B, where it was the lines only crossed in one part at 5x and 4y. Here, the lines are on top of each other, so there are infinite solutions. And because there are infinite solutions, I cannot specifically say which one of those would represent the cost of a burger and which one of those would represent the cost of a salad. So can we determine this? No. Okay, so let's move on to the burger haven. And again, we got 2 burgers and 4 salads costing 32. And we've got 3 burgers and 6 salads costing 42. Okay, so part D says repeat exactly what we did in part B and determine the cost of a burger and a salad. Explain how you can tell that the student must have made an error in at least one of the calculations. Okay, let me read that again really carefully. Okay, I see they're saying, can you determine the cost, just like they asked us in part C. So we'll do the same thing, put those equations into the slope y-intercept form. So I've got 2x plus 4y equals 32. I'll move the 2x over, so I got 4y equals negative 2x plus 32. Divide everything by 4, and I got y equals negative 1 over 2x plus 8. And the second equation is 3x plus 6y equals 42. 6y equals negative 3x plus 42. Divide everything by 6, and I get y equals negative 1 over 2x plus 7. Okay, so what we want to recognize in here is that we have different y-intercepts. So I got 8 and 7 right here. However, I have the exact same slope. So essentially, we've got one of them going through at 7. So if I was to find 7 and draw a line, and it's a negative slope right here, so it would sort of go down like that. Okay, and the next one goes through at 8, and it has the exact same slope. That didn't work out. Now did it? Try again. There we go. Pretend that's going through 8. So what do we notice about these two lines? Well, because they have the same slope and they're going through different y-intercepts, they will be parallel, but not like part C where they were laying on top of each other. But again, can we determine the price of the burger here? The answer would be no. And why? Well, these two lines being parallel will never cross, giving us that intersection point. Okay, moving on to class example 1. It says we got 3 examples here, and we want to take a look at any number of possible solutions. So I think this looks like it's reflecting back on what we just did right here. Okay, so if we look at part A, it says that we have a line, and it's going, it's a straight line, y equals x plus 5, so slope of 1, y-intercept of 5, and it's a positive slope, so it's sort of going off like that in a 45-degree line. And the other one has a negative x, so that would be a negative 1 over 2, which is a negative slope, or sorry, negative 1 over 1, which would, and it's going through point 1, so it's going through around right there. but it's basically going to go down like that. Okay, and what we end up with is one intersection point, and we have one solution. Okay, what about the second one? Well, let's analyze this thing. They have the same slope. They both have a slope of 2/1, but different y-intercepts. So one of them will be going through at -8 down here, and one will be going through at +6 right here. They both have positive slopes of 2/1. So it's going to be sort of like that-ish. And this one would be sort of like that-ish. And we're going to assume those two lines are perfectly parallel. So in this case, we would have no solutions because they will never cross. And part C, okay, well, first of all, recognize that the second equation there we need to put into the slope y-intercept form. So if I move the 2y to the other side, I should have 2y equals 6x minus 4. Divide everything by 2, and I get y equals 6 divided by 2 is 3x. -4 divided by 2 is -2. And look here, we got two equations that are exactly the same. So it's going through a point right here at -2 and creating this line right here. And then the next one is also going through -2 and basically overlaying that line. So in this case, we have infinite solutions. Okay, so let's move down to part D here. So we have a chart right here, and complete the following chart. So it tells us the lines intersect at one point. So that means we got one slope and another slope, and they intersect at one point. So what do we have here? We have one solution. And what do we know about the slopes and the y-intercepts? The slopes and the y-intercepts are different. Okay, and now really we could actually have I'm going to change that. In this case, what I drew, yes, the slope and the y-intercept are different, but we could actually have the same y-intercept. So really, I think the most important thing to recognize there is that the slopes are different. Okay, and the next one says the lines are parallel. We know from what we've done before, this means there are no solutions, and they even give us the answer down below. That means that the slopes are equal and the intercepts are different. So that means I'm going to have one line going off like that and another line that is parallel to like that, but they're going to have different y-intercepts. Okay, and the next one says there are infinite solutions. That means the lines are coincident, which means they're overlapping, which means I've got one and the other one, and they literally go over top of each other. And what do I know about this one? Well, the slope is the same, and the y-intercept is also the same. All right, let's take a look at the class example 2. So it says don't graph it, but just analyze the equations and figure out if there is one solution, no solutions, or infinite solutions. So we need to get these lines, the equations for the lines in A, B, and C all to be in the same format. So you can see the second part of it has it in the slope y-intercept form, except for the last one. They're both out of position. So I'm going to switch this one over to that format. So I've got 5y equals -3x plus 15. Divide everything by 5. We've got y equals negative 3 over 5x plus 3. So what do I notice? Well, I notice it has the exact same slope, however, a different y-intercept. So the bottom one that we just figured out right here has a y-intercept of 3, and the other one would have a y-intercept of 0. So if we have the same slope but different y-intercepts, that means they are parallel, which means there is no solution. Okay, for the second one, I'm going to move the y to the other side and get 4y equals x plus 8. Divide everything by 4. I get y equals 1 over 4x plus 2. So in this case, we've got the exact same slope and the same y-intercept. So this one would have infinite solutions. And the last one is probably going to have different slope, giving us one solution, but let's just figure that out. The first one would reformat to y equals negative 7x plus 12, and the second one would format to, let's see, 6y equals x plus 5, and divide everything by 6. We're gonna get y equals 1 over 6x plus 5 over 6. So one has a positive slope, the other one has a negative slope. They got different slopes, and they also have different y-intercepts. So at some point they will intersect, giving us one solution. Okay, here is class example 3. So basically we've got this situation where it looks like some high school students are making sweaters and selling them, and they obviously want to end up with a profit. So it's going to cost a bunch of money to get them made, and there's going to be a certain number of shirts where they're going to break even and literally have like zero profit, and anything below that number they would lose money, and anything above that number they're going to start making some money. So first of all, if we look at the graph that's supplied, you can see that it's all up in quadrant 1, and the x-axis is going from about negative 10 to 50, and the y is going from about negative 100 up to 1000. So it tells us, what is the x min going to be? Well, I would choose like negative 10. The x max would be 50, and the scale looks like they're going every 10. They're printing out a number. Okay, and on the y-axis it would be negative 100 on the min and 1000 on the max, and the scale would be 100 right here. Okay, so it says that the cost of designing the sweaters is going to be this formula right here, D equals 600 plus 5N. So that means they're paying $600 to a company just to get all set up and have them do the job, and then they're going to pay an extra $5 for every sweater. So N represents the sweater, and D is going to be the cost. Okay, and then the revenue also has D equals 25N. So they're selling each sweater for 25. Okay, so the revenue would be how much they're going to make, and they're making $25 for every sweater that's sold. Okay, so use a graphing calculator to graph each one. So I'll just go do that right now. Okay, so I just want to wait for a second, punched those two equations into the calculator, set my window up like I said, and we graphed it. So here is the graph that we have, and you can see at some point we've got an intersection point, and that intersection point is going to be at 30 in the x and 750 in the y. So the first one is at 30x and 750 in the y, so that would be the intersection point right there. And we've got that one line, which happens to be blue in this case, going from the 0 and up in that direction through that point. And the other one is starting at 600 and going again along and through that point. And this point happened to be 30 in the X and 750 in the Y. Okay, so let's read the next section. How much profit or loss is made if 20 of these sweaters are sold? So 20 is right here on the graph, and basically we're going to have a loss. Okay, so we have to sell at least 30 sweaters and make $750 just to cover the cost and then start making a profit. So basically what I need to do is figure out, well, how much did it cost to make 20 sweaters, and how much did I make, and then subtract the two. So for the cost, I can do it by hand, or I could use the functions on the calculator. But the cost is going to be 600 plus 5 times 20. And 5 times 20 is 100, and plus 600 gives me 700. So that is our cost. And what about the revenue? Well, it says D equals 25 times 20. And that should be 500. So essentially in this case, we lost money because it cost 700 to make it, and we only sold 500, so we had a loss of $200. Okay, now what if we sold 50 of these? Okay, so I'll just minimize this or resize it down, and if we had 50 sweaters, well, as we recognized up top here, we got to sell 30 sweaters to make a profit. So 50 sweaters we're going to make a profit, and essentially we just have to do the exact same thing that we did right there, which is going to be D equals 600 plus 5 times 50, and 5 times 50 is going to be 250 plus the 600 means it cost us $850 to make the sweaters. And how much did I sell them for? Well, 25 times 50, and 25 times 50 is 1,250. So yes, we made a profit, and the profit was the 1,250, which I made, minusing the 850 that it cost to get it made, which gave us a $400 profit. Okay, so the break-even point, again, that is where the two lines crossed right there. So that was going to be at 30 sweaters, costing $750. Okay, and let's see, using a graphing calculator to determine the number of sweaters which must be sold in order to break even. Again, that is 730 sweaters. Okay. And if we were to do this math by hand, just to prove that, we would just take 600 plus 5 times the 30, which is going to be 600 plus 150, which is 750. And if we take the 25 and multiply it by 30, we're going to end up with 750. So if all 850 students in the school purchased a sweater, how much profit would be made? Okay, well, again, really simple. I just want to take that value and of 850 and plug that into there. So the cost is going to be 600 plus 5 times 850, and the amount of money, the revenue make, is going to be 25 times the 850. So if we head over here to the calculator, just quickly clear that screen and go 850 times 5. Okay, so that's 4,250. Add to that the original cost of 600, and we have a total cost to get the shirts made of $4,850. That's the cost. And if we now take 25, which is the cost, the price that we sell each sweater at, and if there was 850 sweaters sold, that would not be plus, it would be times 850, and we get $21,250 in revenue. And basically the profit is going to be the 21,250 minus 4,850. So I take that number and I'm going to subtract the, let's delete that for a second. So it's 25 times 850. Oops, and that didn't work either. 25, I got to use the brackets on here. 850. Hit enter and subtract from that the cost, which was 48.50, and enter. So we made a profit of $16,400. Nice work, student council. Okay, there we go. And the lesson is on, or the assignment's on page 624, and the answers are at the end of that, as always, on page 626. See you in class.